Good morning, everybody. Welcome to another exciting morning of chemistry, Chem 1105, with your host, me, Dr. White. Today's our last Zoom meeting for the semester. Boy, did it go quick. Important announcements. Remember, on Monday, I will be giving the 1105 final online during our Zoom meeting. There will be no Zoom meeting. You'll take the final. And it'll start at 9 a.m. when I send out the email with the password. You'll have until noon to do that. Actual time for this final, because I do it differently for 1105 than I do for 1211, should take you about an hour and 15 minutes max. I'm giving you 3 hours to take it and upload it, and that should be plenty of time. If you're all right, for those who don't see important information, you probably have to log off and log back on, because I realized I hadn't made it visible beforehand. And if you can't see it, email me later today, and I will definitely make sure you can get the information. All right, now I also sent out last night the email update, Chem 1105 update. Please check your Blackboard gradebook to see that all the labs you have submitted to me by either email or on Blackboard as of Tuesday have scores there. Actually, as of last night, because I made sure that the lab that was due Tuesday, if you did it last afternoon or early evening or last afternoon, I've graded that. Plus, also, I'm up to date as of yesterday on extra credit projects. If you see a lab and it doesn't have a score and you submitted it, you have until Saturday morning, this Saturday, 10 a.m., to let me know about missing lab scores. If not, any ones that are missing, I will put a 0 in for that. Remember, Monday, like I just said, at 9 a.m., I will send you the password for the 1105 exam, final exam. You have until 12 p.m. to finish it and upload it. Because of the end of the semester and the deadline I'm under to get grades submitted, anyone who is late submitting the 1105 final exam answers will get 0 points for your Chem 1105 final unless your late submission has been approved by me. All blue card students have a late submission. I'll say it again. Unless you have approval from me for a late submission, if it's late, 0 points, period. I'm on a strict timeline and I can't wait a day or so for someone to figure, oh, I'll upload the test. No, it's a timeline, deadline, you have to be. Blue card students, you have the same deadline that I have given you for tests in the past, because technically this is not much longer than a regular hourly exam, essentially the same. All right, any questions on that? All right, let's move forward. Now, one of the things I didn't cover specifically, and I'll let you do it on your own, is I have in the lecture or in the problem set, key problems for the 1105 final exam. And here's the answer key. and you should know how to do this stuff. And I'm going through it through the actual problem sets, but this is the same as what I've already covered or will cover today. Know how to do these problems. All right, let's get started. Let's go through test 3 review. We will not have a lab today because we're done with labs. Oh, that reminds me, I want to do something real quick before we get started. We got plenty of time. You'll get out early today. All right, I'm going to send out a poll and it says, are you done? Instead of are you done, I'm going to ask you the question, did you like using Beyond Lab Z? Yes or no? It's totally anonymous, so don't worry. Again, the question I'm asking for yes or no, did you like Beyond Lab Z? All right, I think that's everybody's filled in. So thank you for your answers. All right, let's get back to the review so you do well on the final. Before I do that, remember the best way to study for the final is one, look at what I just showed you, the final review or the final exam practice problems, do them. Also look at your hourly exams and use those as practice problems, do them. Practice helps you get a good grade. Hopefully you've learned that by now this semester. All right. And I still haven't fixed it. I apologize. Gases, remember, and this should be 760 torr equals 760 millimeters of mercury equals 1 atmosphere. Next, Kelvin is degrees C plus 273. I taught you gas law, Boyle's law. P1 times V1 equals P2 times V2. P1 initial pressure, V1 initial volume, P2 initial final pressure, V2 final volume. And let's take a look at a couple of practice problems. How many atmospheres? Number 3 is 741 torr. Note, and I have it here right, 1 atmosphere, and this will be given to you, important information, final exam. 1 atmosphere equals 760 torr equal 760 millimeters of mercury. I'm at 741 torr. Want to go to atmospheres. I use my good buddy, my good friend, unit analysis. Atmospheres goes on top. What I'm trying to get rid of goes underneath. Where do I get the numbers for the ratio? 1 atmosphere, 760 torr. Remember, 1 and 760 are exact numbers. So you start out with 3 significant figures, 741, your answer 3 significant figures. Now, if we look at number 6, if a balloon has a pressure of 658 torr and a volume of 1.894 liters, what's the pressure of the balloon if the volume is increased to 5.133 L is liters volume? What are we being asked to find? The final pressure, the pressure after we make a change, P2. The initial pressure, P1, is this. The initial volume is this. The final volume after you increase it is this. And we use Boyle's law, P1 times V1 equals P2 times V2, which reminds me, I shouldn't be lazy on the last day. So on your screen, important information, final exam. I highly recommend you look at this before you or while you're doing your studying so you know what you should know how to use. And here we have Boyle's law, P1 V1 times V1 equal P2 times V2. I give you what P1 V1 P2 V2 are. And now we want to get P2 alone on one side. How do we get rid of V2? Divide by it. Whatever you do to one side, you have to do to the other. Anything divided by itself is 1. 1 times P2 is P2. I rewrite it, put the numbers in, and remember, use proper significant figures for all calculated answers. When you do multiplication division, the number you get has the same number of significant figures as the number that you multiply and divide that has the fewest, 3, 3, 4, therefore 3 significant figures. Next, my favorite is the ideal gas law, PV equal nRT. And P is pressure in atmospheres, V is volume in liters, N is moles, T is temperature in Kelvin, R is the universal gas law constant, 0.0821 atmospheres, liters, mole K. Let me remind you, R is a calculated value. Here you have 3 significant figures. This is not an exact number. It's 3 significant figures. Oh, wrong thing, right thing. And let's look at number 10. I like this. If you burp 86.75 grams of CO2 at 545 millimeters of mercury at 34.6 degrees C, what's the volume of your burp? Now, first of all, we're dealing with a gas. Notice nothing has changed. Temperature, pressure, you're trying to calculate volume and the amount. That immediately should tell you PV equal nRT. Also, 15 points might be an indication too. Uh-oh, I gave something away. So what are we trying to find? Volume. What are we given? A weight, a pressure, temperature, and if you look at important information, which I can do right now, you're given R right here. So we want to solve for V. How do we get it alone? We get rid of P. How do we do that? Divide by P. Whatever you do to one side, you'd have to do to the other. So now we know to solve for V, we have N times R times T divided by P. But N is moles, and you're not given that. P and T, pressure and temperature, have to be in the correct units. And if you forget, once again, look at important information. Pressure has to be in atmospheres. I'll always give you volume in liter if I give it to you. Moles, N is moles, and temperature has to be in Kelvin. And if you notice, I have the way of converting Kelvin, Celsius to Kelvin, and also the correlation atmospheres to torr, millimeters of mercury. So what do? We say, how do we get atmospheres? Here's what we're starting with. Here's what we're trying to get to. Use unit analysis. This goes on top. This unit goes underneath. Where do we get this? 1 atmosphere equals 760 millimeters of mercury equals 760 torr. Exact numbers, 3 significant figures. Answer, Kelvin, degree C plus 273. Degree C was 334.6. Here's the number you get. And finally, moles. We're at grams. We want to go to moles. Unit analysis. This goes on top. The unit we want to get rid of, grams CO2, goes underneath. Where do we get this relationship? 1 mole of a compound equals the molecular weight of that compound. We went through this yesterday. Molecular weight, sum of atomic weights. In case you forgot, don't forget important information. 1 mole of compound equals its molecular weight of that compound in grams, and the molecular weight of that compound is the sum of all atomic weights of the compound, which I do. This is 4 significant figures, exact number 44.0, which is the molecular weight of CO2, is 3. So my answer is 3. Now, I put in the numbers. Remember, we solved V equals nRT divided by P. Here's N, here's R, here's temperature, here's pressure. 3, 3, 4, 3, 3 significant figures. Now, since it's a multi-step calculation, you can either round off at each step, which is what I like to do, or at the end. I will calculate it both ways. In this case, both ways equal the same number. You should know how to do problem 10. And next we have the ideal gas law. The ideal gas, I just did this. Remember, the ideal gas law, PV equal nRT, tells you when it gets cold outside, check your car tires, because temperature goes down, pressure will go down. In the summer, it gets hot. We didn't have that hard of a summer here. I'm gonna keep my mouth shut. But if it gets real hot, temperature goes up, pressure goes up, check your car tire pressure. All right, finally, Dalton's law of partial pressures. The total pressure of a mixture of gases equal the sum of the partial pressure of each gas in that mixture. And the partial pressure, which I'll never ask on a test definition, but you should know how to do, is the pressure of a gas if it were alone in the mixture. Next, I talked about boiling points, and that's when boiling point of a liquid is when the vapor pressure of a liquid equals atmospheric pressure. The higher the altitude you go on Earth, the lower the atmospheric pressure, therefore the boiling point is lower. And I did ask a question like that on test 3. Let's talk about solutions. Solutions contains a solvent, which is the component present in the greatest amount, and then solutes. Now, something that you think might be a solution, but is not, is a colloidal dispersion. And it's when you have particles suspended in liquid. And it's not a solution. Why? Because those particles are large enough to scatter light. And examples, which I don't have, would be paint, blood, and mayonnaise would be another one. And I'm forgetting a third one, but anyways, those would be key ones. Remember, like dissolves like. Like solutes are soluble in like solvents, which means polar solutes are soluble in polar things. Non-polar solutes are soluble in non-polar solvents. And water is the most polar thing. Vegetable oil, salts are polar too. Vegetable oil, gasoline, Vaseline, and baby oil are non-polar, so is dirt. And remember certain key definitions: the solubility of the solute, the maximum amount of solute that will dissolve in a given solvent. Saturated solution that contains the maximum amount of solute that can be dissolved under conditions that exist. Dilute has a small amount of solute relative to the amount that could exists concentrated. You have a large amount of solute that could be there. And you should know aqueous solution, a solution in which water is the solvent. I don't have it down here, but that's bracket AQ, close bracket. And we talked about concentration, and the only concentration that I'm going to ask you to know for the final is molarity. Molarity is capital M, and the molarity of a solution is giving the number of moles per liter, but since 1 liter equals 1,000 milliliters, that's also moles of solute per 1,000 milliliters. Ooh, know this. And for determining molarity, there's a two-step problem I'm going to go through right now. But before I do the two-step, all right, well, I guess I'll do a problem from the problem set for the final. How many? Let's see. Let's do number 9 first. Yep, let's not do number 9. Hang in there. All right, found what I was looking for. Sorry for the delay. The one I should have known as a colloidal dispersion that I had a brain freeze, milk. All right. I highly recommend you go through the problem sets. All right, let's look at number 8. Well, let's back up one. Let's look at number 7. What does, and let me blow it up for you and let me make sure you can see it. All right, what does 4.56 times 10 to the third capital M NaCl bracket AQ close bracket mean? And what's the solvent? Capital M molarity. So it's these many moles of sodium chloride per 1,000 milliliters, and the AQ tells you solvent is water. Let's look at number 8. How many moles of sodium chloride are in 125 milliliters of a 3.45 capital M NaCl solution? We have, what are we trying to find? Moles of NaCl. What are we given? The volume. And this 3.54 capital M NaCl, capital M, molarity. You go, what does this mean? 3.45 moles of sodium chloride per 1,000 milliliters. And what time is it? It's time to use your good friend, your good buddy, unit analysis. Oh, I love that. And here's what we start with, because that's what we're given. We're trying to get the moles of sodium chloride. Moles go on top of the ratio, milliliters go underneath. Where do we get these numbers? From right here. Capital 3.45 capital M NaCl really means 3.45 moles of NaCl per 1,000 milliliters. And that's where you get the numbers in the ratio. 3 significant 3. The 1,000 is an exact number. My answer is 3 significant figures. Now, the real life problem is 10 points. How many grams of sodium chloride are needed to make 345 milliliters of a 6.789 capital M NaCl solution? We're trying to find grams of NaCl. We're given milliliters and we're given 6.789 6.789 capital M NaCl, which you immediately should know is 6.789 moles of sodium chloride per 1,000 milliliters. There is no way I can go directly from milliliters to grams. There's no way I can go directly from milliliters to grams. So what do? Well, I look at important information. I see molarity, and I say, oh, molarity, two-step problems. Step 1, milliliters to moles. Step 2, moles to grams. Notice overall milliliters to grams, but in 2 steps. Therefore, I'm going to do that. And I did. Step 1, milliliters to moles. Here's our milliliters, which we figured out. We want to go to moles, use unit analysis. Moles go on top of the ratio, moles NaCl. Milliliters go underneath. Where do I get these numbers? From the molarity, which I knew was 6.789 moles of sodium chloride per 1,000 milliliters. This is an exact number, 1,000. The other are three significant figures. But this is moles of NaCl. I wanted to get to grams of NaCl. Therefore, I need to do step 2, and that is moles of, this case, NaCl. I want to go to grams, use, oh, I have to do it again. Use your good buddy, your good friend, unit analysis. Grams go on top, moles go underneath. Where do I get a relationship between moles of a compound and grams of a compound? Well, in case I forgot, I'm going to go to my important information and notice 1 mole of a compound equals the molecular weight of that compound in grams, and the molecular weight is the sum of the atomic weights. And the molecular weight of sodium chloride, remember, test the final exam, it will say under your name, please use proper significant figures for all calculated answers. And it will also say, please use 3 significant figures for all atomic weights. If you don't, I take off points. Therefore, sodium 23.0, chlorine 35.5, added up, the molecular weight is 58.5. Put that in there, 1 mole per 58.5 grams. Do the math, 3 significant, 3, 1 is the exact number. And you get 137, 3 significant figures. And again, multi-step calculation, you round off at the end, or each step, I'm a round off each step guy. And I should say person, not to be sexist. And therefore, you get 137, but if you round off at the end, you get the same number. Whoa, we're moving along quickly here. All right, any questions about test number 3 material? My speaker's on. When I first started doing Zoom, I'd forget to turn on my speaker the first couple. I don't hear you guys. Are you talking? Or I forgot to check, is my mic on? Like now. Now you can hear me. All right, let's move on to test number 4 material. And this dealt with acids and bases and organic. Of all the material I'll teach you this semester, these 2 chapters are probably the most important for your daily life and also for your professional life. Excuse me. All right, you should know Bronsted-Lowry acid, proton donor. Bronsted-Lowry base, proton acceptor. Acids, you should know acids by their formula, not their name. Hydrochloric acid, HCl, H2SO4, sulfuric acid, HNO3, nitric acid. bases NaOH, sodium hydroxide, base KOH, potassium hydroxide, base NH3 ammonia. Because water can react with itself in the following reaction, there's something called the ionization constant for water, Kw, named after me, I wish, but those are my initials, so it always brings a big smile to my face when I see it, and I'm smiling now. Anyways, that's the hydronium ion concentration equals hydroxide. That should be 1.0 times 10 to the minus 14. And it's at room temperature. Next, I taught you acidic solution. Hydronium H3O concentration is greater than hydroxide OH minus. For basic, it's the opposite. OH minus hydroxide concentration is greater than the hydronium H3O. And finally, neutral OH and H3O are equal. Next, I taught you the pH scale. And the pH scale is pH equal minus the log of the hydronium ion concentration. And here we have my gift to you. If H3O plus is 1.0 times 10 to the minus X, and you put it in here for pH, then the pH is X. And let's take a look at the important information. Final exam. Notice, whoa, I should take that out. But I tell you what an acid and base are. Here's the pH. I may have to change this a little. I forgot to put titration in there. And remember, this is probably one of the most important things I'll teach you. The pH scale goes from 0 to 14. At 7, halfway between 0 and 14, neutral pH. Above 7, basic. Below 7, acidic. When you have something at neutral pH and you add an acid to it, the pH will go down, making it acidic. If you have something at pH 7, you add a base to it, the pH goes up, you make it basic. And here I have that again, what I just said. Remember, buffers are solutions that resist change in pH when small amounts of acid and base are added to it. And if you look at test number 4, here's a question I had on there, which are the following: acid, base, or salt. And then let's look at number 4. If the solution has a pH of 1.0 times 10 to the minus 3, what is the pH of that solution? Is it acidic, basic, or neutral? And the pH is what we're trying to find. We're given this. We have pH equal minus the log of the hydronium ion concentration. Put that in. Notice it's 1.0 times 10 to the minus X. In this case, X is 3, pH is 3, it's less than 7, it's acidic. Now, as I gave on test number 4, if a solution has a hydroxide ion concentration, OH minus, of 1.0 times 10 to the minus 3, then what is the pH of the solution? And is it acidic, basic, or neutral? Well, pH, we're given hydroxide, but pH equal minus log of hydronium ion concentration, H3O plus. Oh no, we need 2 steps. First one, you have to convert OH concentration into hydronium. How do you do that? Use Kw, no, not me, but Kw, the ionization constant, equals hydronium concentration, hydroxide, 1.0 times 10 to the minus 14. You solve for hydronium, divide both sides by hydroxide. You get this. Hydronium equals this. Put the numbers in. It's 1.0 times 10 to the minus 11. Are we done? No. We're trying to find pH. The 1.0 times 10 to the minus 11 is the hydronium ion concentration. Second step, you put hydronium into, convert hydronium to pH, pH minus log of H3O plus, put the number in, that's 1.0 times 10 to the minus 11. In this case, when it's 1.0 times 10 to the minus x, pH is x, in this case 11. 11 is greater than 7, therefore this is basic. Remember, when you neutralize an acid with a base, you can use that to find the molarity of the acid or the base, and this is called the titration. And at neutralization, moles of acid equal moles of base, which means milliliters of acid times molarity of acid equals milliliters of base times molarity of base. And if we look at number 12, if you have to add 1.35 times 10 to the third milliliters of a 1.53 molar NaOH solution to neutralize, that's the key. To neutralize 1.87 times 10 squared milliliters of an aqueous HCl solution, what is the molarity of the HCl solution? What are we trying to find? Molarity of HCl. We're given milliliters and molarity of NaOH, the base. We're given milliliters of the acid. Moles of base equal moles of acid, milliliters of base times molarity of base equal milliliters of acid times molarity of acid. We put the numbers in. Oh, we have to solve for molarity of acid. How do we get that alone? We divide by this number, this side. Anything divided by itself is the number 1. That cancels out, but whatever you do to one side, you do to the other. I did. I'll now rewrite this, put the numbers in, 3, 3, 3, 3 significant figures. And that's how you do a titration. I gave you some more examples. Oops, not what I wanted to do. Next, we talked about carbon atom. And on this page, the most important thing you should know, how many bonds to carbon? How many bonds to carbon? 4, 4, 4. Does this seem like it's coming right at you? It is. And when I teach organic, I brainwash my students, there's 4 bonds to carbon. You should know what is a hydrocarbon. A hydrocarbon is a molecule or molecules with only carbon and hydrogen atoms. You should know that there are 2 types of hydrocarbons. Saturated hydrocarbons are hydrocarbons, and since it's in a hydrocarbon, it's a molecule with only carbon and hydrogen atoms, which all carbon-carbon bonds are single bonds. What is an unsaturated hydrocarbon? It's a molecule with only carbon, hydrogen atoms that contain 1 or more multiple bonds, or you could write just double or triple bonds. By the way, the greatest of all organic chemists is Mother Nature. Just look in the mirror and you can see her work. your hair, your skin. You should know, how do you find a functional group, which is a grouping of atoms that always react the same way in a molecule. You look for anything that's not a carbon atom, C, a hydrogen atom, H, or a carbon-carbon single bond. And I taught you how to draw structures, in our case, how to put in hydrogens. I talked about ring cycloalkanes, and every bend in a line is a carbon. And before we go to combustion, these questions I've already gone through. And how do you draw carbon atoms? Well, you count the bonds. There's 4 bonds to carbon. If not, the remainder are hydrogen. And here's one for you to do, say 3 points each. Write in the hydrogens for the following molecule. Go. And when you're done, give me a thumbs up. Remember, there's 4 bonds to carbon always. All right, let's do this. There's 4 bonds to carbon. I look at this carbon, I see 1 bond. 4 minus 1 is 3. So I'll put in 3 hydrogens. Same here, same here. Same here, same here, and same here. Now let's look at this one. There's 1, 2, 3 bonds. Therefore, 4 minus 3 is 1. So this gets 1 hydrogen. If we look at this carbon, there's 4 bonds to it. 1, 2, 3, 4. 4 minus 4 is 0. No hydrogens. If we look at this carbon right here, there's 1, 2 bonds to it. And therefore, 4 minus 2 equals 2. And I'll put that in there. And finally, the last carbon, there's 1, 2, 3. 4 minus 3 is 1. And that's how you do it. And you should know how to do that. And with that, let's take a break. Let's come back at 9:55. I'm going to get up and stretch. I'll see you in 5, approximately. It's time to get started. All right, we're finishing up review for the final exam. Don't forget, the final exam will be this Monday at 9 a.m. There will be no Zoom meeting. One other thing, I'll put an email to you when I do. Hold on, I got dirty glasses. Oh no, dirty glasses. Super dirty glasses. They work now. Don't forget, no Zoom meeting. I will send out the email with the password on Monday at 9 a.m. You'll have until 12 to get your final exam answers back to me. I would highly recommend before you upload them, check your file, your PDF file, that you have included all answers for all questions. Last test, I had 2 or 3 people who missed the whole page, like 10, 12 points. I was nice enough to reach out for them for the final exam. I probably won't have time to do that. Check and make sure you have all answers in your PDF file. Also, I'll have an email on Monday. Once I send out the email, I will check my email about every 10 or 15 minutes during the whole time of from 9 until noon. If you have any questions or problems, email me and I'll help you out. Because remember, the first day I said it, and the last day I'll say it again. My class, in my world, there's no such things as a dumb question. And therefore, let's get back to important questions. Now, next thing I taught you was 2 general reactions. I taught you how no matter what the molecule, if it's that type of molecule reacting under certain conditions, you get the same kind of product. If you have a saturated hydrocarbon react with oxygen, you need a spark or a heat source, but I don't put that down. You get carbon dioxide and water. You don't have to put down the heat. And the other reaction I asked you to learn was hydrogenation. If you have a molecule with a double bond, you break 1 of the 2 bonds, and each carbon double bond gets a hydrogen. And the other thing which I had on the test, you should know how to count carbons in a molecule. If we look at B, count every C, 1, 2, 3, 4, 5, 6. But this ring here, every bend in a line is a carbon. 1, 2, 3, 4, 5, 6. 6 plus 6 is 12. And that was on test number 4. And finally, I also had circle a functional group. Notice oxygen, O here, O here. Nitrogen. Well, this is the one I actually had on the exam. Anyways, you should know how to do this. And finally, give the reaction products for the following. And notice I have a saturated hydrocarbon oxygen. Therefore, I'm going to get CO2 and water, and that's what I get. And for double bond, oh, let's look at E. That looks pretty. Look for what's different. What's not a carbon-carbon single bond or carbon hydrogen should get your attention like that. Or like this. I had to slip that in one more time. And double bond, general reaction, hydrogen and catalyst. Catalyst can be nickel, platinum, or palladium. You break 1 of the double bonds, and each carbon gets a hydrogen. You don't break carbon-carbon single bonds. Start with 2, 4, or in this case, 3, 6. We end up with 3, 6. The 2 carbons with the double bond break 1 of the bonds. Each one gets a hydrogen. And I will not ask about tallow and yellow grease. However, this is probably one of the two most important things I will teach you this semester. You should know this. How does soap work? Soap has the structure, non-polar tail, polar head. Water is polar, dirt is non-polar. The most important thing, which is why I wrote it real large, how soap works is like dissolves like. We have a dirt particle. When you use soap and water, you form a micelle, which looks like this. The soap nonpolar tail is attracted to the dirt nonpolar because the like dissolves like. The polar heads are on the outside, totally surrounds the dirt, forming a micelle. The water sees the micelle as polar, and water says to the micelle, I'm polar, you're polar, let's go down the drain together. And they do, and your hands are clean. You should also know, how does a towel work or absorb water? And the answer is hydrogen bonding. Want to have anything about fats and oils? I should have taken that. Same thing here. I just went through how soap works. Talked about micelles already. Know this. Really. Get the hint? Know how soap works. No pH. How does a towel work? All right. The first day of class, I said, my world of work of chemistry is your world of chemistry. You don't know about it. Now you do. And now I can say, my world of chemistry is your world of chemistry, and you do know about it. Next time you go outside and feel the wind on you, that's molecules hitting you. And you know what that is. And you know how atoms are held together by bonds. Next time, oh, that's a liquid. And you know gas, liquid, and solid, the three states of matter. And you've learned a lot of things. And with that, I'm done. I've done my job. Study so you do your job and you get a good grade in my class, because it makes me far happier to see students succeed than not succeed. So don't you want to make me happy, please? And with that, I'm going to try a new ending before I say gehen gesund. This is from my childhood. Until we meet again, happy trails to you. Keep smiling until then. Who cares about the clouds? I like to wish happy trails to all of you. That was the way the Roy Rogers show ended always. And with that, for the last time this semester, gehen gesund, be healthy. Remember, it's dangerous out there. The Delta variation is really taking hold, dangerously so. Wear masks. If you don't have a vaccine, you haven't gotten your shots, especially both of them, get them. It will save your life. I got mine as soon as, in fact, it took me about 5 weeks beginning of this year more before I could get an appointment in April. And I was really upset that it was taking me that long. But when I got it, and I don't react well to vaccines, this one I had no problems with, other than I used to have a full headache. No, I didn't. But get your vaccine. And with that, If you have any questions, always feel free to email me. And with that, I'm going to say, Gang gesund, goodbye. Don't forget about Monday, the final.